Okay, geometry, this is chapter 10, section 2. Pause the video, come back and check your work. So you should recall the relationships of the sides in a 30, 60, 90 triangle. And remember that the hypotenuse is 2 times the smallest length, but the smallest side would be 1. And then the middle leg, or the larger leg, is the smallest side times the square root of 3, or 1 times the square root of 3. In a 45, 45, 90, we have the legs equal, and the hypotenuse is the leg, a times the square root of 2, right? There you go. And then we have, again, another 30, 60, 90. Okay. Today, we're going to develop and apply the formulas for the area and circumference of a circle. We will also develop and apply the formula for the area of a regular polygon. So be sure you understand and know these words. The new word is center of a regular polygon. That's a new phrase. Apothem is the new word. Central angle of a regular polygon. So the locus of points in a plane that are a fixed distance from a point called the center of a circle would be the circle. The points themselves on the circle are a fixed distance from a center point. We name a circle by this symbol. Looks like a target. And its center. Circle A has a radius equals AB. Radius, recall, goes from a center point to any point on the circle. And circle A has a diameter of CD. The irrational number pi is defined as the ratio of the circumference, flip around, to the diameter, or pi equals circumference divided by diameter. We can solve that equation for C, simply multiply both sides by D, right? And we end up with this C equals pi D. Also, recall that a diameter is 2 radius, right? So we could substitute 2r for d, and when we do, we see this written as c equals 2 pi r. You can use the circumference of a circle to find its area. Divide the circle and rearrange the pieces to make a shape that resembles a parallelogram. So if we take all 8 pieces in this circle and we place them in such a way that 4 are kind of pointing up and 4 are pointing down, we have something that's getting close to a parallelogram. We just have this extra little curve on the top of each, I guess what could be called the base of a triangle, right? So we see that we have 4 pieces of that circle here and 4 on the other side. So if we were to imagine this as almost a parallelogram, 4 pieces make up the base, right? And that's half, isn't it? Half of the circumference. So, and then the height is made up by the radius, isn't it? So we could say that the base of the parallelogram is half the circumference. If the circumference is pi 2r's, right, then this base now is pi 1r, right? And then the height would be about a radius, right? It would be a radius, so we have pi r times r, or area equals pi r squared. Okay? This should be area equals pi r times r, or pi r squared. The more pieces you divide a circle into, the more accurate the estimate will be. These little curves will be smaller and smaller, and this will be a more accurate polygon. So we have a little rule box. Okay, so a circle with diameter d and radius r, we could say circumference equals pi d, or 2 pi r, and the area equals pi r squared. Let's find the area of circle K in terms of pi. When it says in terms of pi, what do? Yeah, we don't calculate the answer to any decimal value. We simply leave pi in the answer, this little symbol. Okay, if we're asked to find the area, what shall we start with? A equals pi r squared, the area. And now we have to find r to find area. If the diameter is 6 inches, the radius will be 3. Good. And so we substitute 3. And now we simply square 3 and leave the pi as it is. So area equals 9 pi inches squared. Our units are inches. Remember, they will be squared. Good. Go ahead and try it again with this interesting circle. We're going to find the radius of circle J if we're given circumference is 65x plus 14 pi. So again, what do we start with? The formula, right? C equals 2 pi r. We're asked to find the radius, so we want to see radius in our little formula, right? And now simply substitute our known value for C. 65x plus 14 equals 2 pi r. And now we need to isolate r. So what will we do? That's right, divide both sides by 2 pi, right? When we divide by pi on both sides, the pi's cancel out, don't they? And then 2 must be distributed into both of the numeric terms here, right? And so we have 32.5x plus 7 equals our radius. We're trying to look at all the variety of questions one could be asked, and here you're asked to find the circumference of circle M if the area is given to you as 25x squared pi. So we begin with the area formula because that's what we're given is area. To find circumference, what do we need? Yeah, we need the radius or we need diameter, right? So we start with what we know, and we can substitute the known value for area into the A, right? And can we now solve for r? What would you do first? That's right, we'll divide both sides by pi, giving us 25x squared equals r squared, and to find r, we simply take the square root, and we have r equals 5x. Okay, if we have r equals 5x, we can now go find the circumference. So let's jot down our circumference formula, and now we substitute the radius that we just found, right? And when we do, let's simply solve. What property can we use to multiply 2 and 5 together? That's right, the commutative property, so we do. And we end up with 10x times pi feet. This is the circumference. Okay, now we're going to find the area in terms of pi when given circumference. So we know circumference, and to find area we'll need what term? That's right, radius. So let's start with our circumference formula. And you know, they jump straight to, we know we need to find the area. And so to find the radius, they use circumference and they don't begin there. So go ahead and do it, come back and check your work. Let's think about it. Circumference equals pi times d, or 2r's, right? So this would be the diameter. So half of this would be a radius. So can we just multiply this by half, or divide each term by 2? Yes, and there's your radius. And so we now have, after multiplying, remember this is the square of a binomial. You might want to expand that to 2x minus 3 times 2x minus 3. Hopefully you don't have 4x squared plus 9, the number one error, right? Don't forget there's a middle term when we have the square of a binomial. Remember, the pi key on your calculator gives you the best possible approximation for pi, and always wait until the last step to round. All right, and go ahead and try this cooking application. Come back and check your answer. When given a diameter, we simply divide it in half, and we use the radius to find the area. Good job, I'm sure there's no problem there. This is the interesting section of today's lesson. The center of a regular polygon would be how far from the vertices? If it's a regular polygon, remember all sides are congruent, right? So the center would be equidistant from each vertex. So what is the distance from the center to a side? So not to a vertex, but from the center to a side. We call this interesting word, the apothem. So a central angle of a regular polygon has its vertex at the center and its sides pass through consecutive vertices. Let's draw a regular polygon so we can see this. So here I have, I'm hoping it's a regular polygon, right? That is, what would you call that? That's right, a pentagon. So the center would, of course, be equidistant from each of the vertices, right? Each one, same distance, okay? The apothem is the distance from, let me grab a segment here, from the center to, perpendicular distance to any side, okay? Okay, so how can we find the number of degrees of a central angle? Now here's a central angle, okay? It's made by drawing a segment from consecutive vertices to the center, right? We can draw them all the way around. And because this is a regular polygon, each of these angles formed should be congruent. And this is a 5-sided pentagon, so how many central angles do we have? We have 5, right? And one trip around the center of a polygon has the same number of degrees as you would find in a circle, right? 360. So if you would like to find just a single angle, one of these central angles, because each of these triangles is congruent, right? We simply take 360 degrees and divide by the number of sides. And so we have this little equation here that says for any polygon with n sides, so an anagon, right? You simply divide 360 by the number of sides and you'll know what each central angle's measure is. Okay, here's another drawing of a pentagon DEFGH, and we have center C. Here's an apothem, which is a segment from the center perpendicular to a side, and we have central angles, DCE, and so on. Okay. So if we want to find the area of a regular polygon with side lengths S, so the side lengths would be these sides out here, right? And apothem A, divide it into n congruent isosceles triangles. So look at this. Each triangle formed here, all 5, have congruent to congruent sides, right? They're all isosceles triangles of the same size. And they each have a height that is the same as the others, right? They all have an apothem that is the height. And so the area of each of those triangles would be half of base times height. Half of the base S times the height apothem, right? The total area then of the polygon would be the number of sides of the polygon, which is the same as the number of triangles, times the number, or the areas of the triangles, right? Half of base times height. So when we distribute this, we know that the number of sides, or the length of a side, times the number of them gives you the perimeter of the polygon. Length of side times 5 would give you a walk around this entire pentagon, right? And so we can find the area of a polygon by using the perimeter as a base times the height apothem and divide by 2. So it's like our triangle formula spread across the entire polygon. It's as though we disconnect and just lay all these triangles out in a row, 5 in a row. We find all their bases times height and divide by 2. It's really kind of nice. So here we have the rule box for the regular polygon area. Area equals half times the apothem times the perimeter. You get all triangles using this formula. So let's use that to find the area of a regular heptagon with side length 2 feet to the nearest tenth. Okay, so we'll start. We could draw the heptagon, the isosceles triangle with its vertex. At the center of the heptagon, the central angle is 360 degrees divided by 7, right? And so the central angle is actually 51.4 degrees. So now we can draw a segment that bisects the central angle and the side of the polygon, and that's our apothem, right? So when we do that, let's look back here. We know this big central angle is 51.4, right? And now we're bisecting that angle to form a little right triangle here, or 2 congruent right triangles, right? And so we have split that 51.4 degree angle in half. And so we can use that now to find our, remember we know the side length is 2. Okay, so down here we have a side length of 2. We've also split that side in half. So we can now use our trigonometric ratio, right? The tangent of our 25.7 degree angle equals 1, which is half of a side, opposite over adjacent, right? The adjacent is the apothem. We simply isolate A now. We can multiply by A and divide by tangent 25.7 and solve for our apothem. And when we do, we find that we can substitute the apothem and the perimeter into our area formula, right? And there we go. We have the apothem, and we know that there are 7 sides to this type of polygon, right? And each side has a length of 2. So we have a perimeter of 14, and we simply solve for the area, 14.5 feet squared. Remember, the tangent of an angle in a right triangle is the ratio of the opposite leg to the adjacent leg, right? See if you can find the area of a regular dodecagon with side length 5 centimeters to the nearest tenth. Now a dodecagon has 12 sides, okay? So the first thing we need to do is find what is that central angle in a dodecagon. And so you're going to take 360 and divide by the number of sides, 12, right? And we know that the central angle is 30 degrees. So again, now we will bisect that central angle to draw your apothem, right? And so that little new angle formed there is that's right, a 15 degree angle, okay? Go ahead and use the fact that we know the side length is 5, and we have a little angle in our right triangle of 15 to find your apothem. And there we go. We split the side in half, so we have opposite, 2.5, over the apothem equals tangent of 15 degrees. Now when we isolate A, we have 2.5 over tangent 15 degrees. There's your apothem. What would the perimeter be for a 12-sided figure when each side is 5? That's right, I'm sure you have it, and that would be 60. And now we simply use our area of a polygon formula, and you should have 279.9 centimeters squared. Okay, try this lesson quiz, and please come back and check your work. Number 1, 2. Please pause, come back. Do try this and check your work. And for a nonagon, 9-sided, and for the octagon we have an 8-sided, right? And there you go.